Hey there, my name is Vedanti Ramkrishna Ramkane and my teammate is Sanvita Snehi, and we are working on water level monitoring system OPAmp comparator circuit, and the component we have used are OPAmp 741, which act as a comparator to monitor water level, then resistor R1 and R2, which forms a voltage divider that provides a fixed reference voltage to the inverting input of the op-amp, then resistor R3, which limits the output current of the op-amp, protecting the circuit, then input signal generator, which is XPG1, we simulate the water level by providing a variable input voltage to the non-inverting input of the op-amp. Then oscilloscope, which is XSC1, which display the output from the op-amp showing whether it's high or low. So in short, working of the circuit is when the input voltage, which is from XPG1 representing water level, is below the threshold set by R1 and R2, the op-amp output remains low, and when the input voltage exceeds the threshold, the op-amp output goes high, indicating that water level has reached a sufficient high and can trigger actions like turning on pump or alarm.
So now let's look at the use of the circuit as a water level detector. So this circuit acts as a water level detector by monitoring the water level voltage against a set threshold. So when the water level falls below this threshold, the op-amp output goes high, which can trigger a pump or an alert to refill the tank. So once the water level rises above the threshold, the output switches low, indicating a safe water level. Now let's look at the output waveform shown on the oscilloscope. So we have two waveforms, the sine wave and the square wave. So the sine wave represents our input signal, which simulates the varying water level in the tank, and the square wave, it represents the output of op-amp. So here's how to interpret these waveforms. Like as the water level fluctuates, that is the sine wave, whenever it drops below the setted threshold, the output jumps to a high state, and this high state in the output waveform indicates that the water level is below the threshold, which could be used to signal that the tank needs to be refilled. But when the water level rises above the threshold, the output waveform switches back to a low state, meaning that the water level is safe. So this toggling behavior between the high and low states based on the water level helps us monitor and control the tank level efficiently. So in the summary, the output of the comparator circuit, it directly reflects whether the water level is above or below of our defined threshold, making it a reliable indicator for water level monitoring.